In this video, we'll discuss the history of atomic theory and the development of the periodic table. Starting around the 1800s, John Dalton made postulates or claims about matter. So he said that matter is composed of tiny little particles. He called them atoms. He said that atoms of the same element are the same, but they're not the same as other elements. They can't be created or destroyed. They can't be converted into other elements. And then he also said that these atoms are combined in different ways, whole number ratios, that make chemical compounds. Now, those compounds were well known to scientists at the time, but they wanted to see how we could take those compounds and break it down into its smallest unit. So a lot of scientists were taking known substances and trying to isolate the pure elements that would make up those substances. Based off of the data from these experiments, Dmitry Mendeleev developed the first periodic table. He arranged elements based off of mass and based off of their basically physical and chemical properties. What was really neat about this is he was able to make predictions and predicted the properties of elements that hadn't been discovered at that time. Then J.J. Thomson discovered the electron. He saw that atoms had a negative component, and so he developed the plum pudding model, where there's a matrix of positive and then negative spread out. And he said that the negative part these were electrons. He didn't call them electrons at the time, but he was talking about electrons. He did this through a cathode ray tube, and essentially it was negative particles that were attracted to a positive side. So he was able to use that to see that atoms had different charges within the atom, specifically the negative charge. Then you have Rutherford, who discovered the nucleus, and he did this through the gold foil experiment. He shot alpha particles at gold foil and noticed that they passed through, but every once in a while the particles would bounce back, and he said that was due to mostly empty space in the atom with a very tiny and very dense nucleus, which is what would bounce those alpha particles back. Niels Bohr discovered that electrons can be found on different energy levels. He did this with spectroscopy. He passed electricity through hydrogen and noticed that it would produce light. And this light was at specific wavelengths, and he said that was due to the different energy levels of the electrons. Moseley discovered the atomic number. Essentially, he said that elements in the periodic table should be arranged by their atomic number, the number of protons they have, as opposed to their mass. And that explains the reactivity a little bit better than just doing it by mass. For the most part, the old periodic table worked out, but there were a couple examples of where atoms should have been arranged by atomic number as opposed to mass. Then the most recent is the quantum mechanical model that says that electrons act as waves and particles, and that instead of electrons orbiting like planets orbiting the sun, they are in different orbitals and different shapes, and they make up a cloud of electrons. And you can't know the position and momentum of electron or the speed. And it is much more complex than anybody thought at that time.